Hello everyone, so this video will be about the central tendency measures. So the central tendency actually gives a single value that represents the center of or the typical behavior of the entire dataset. It simplifies complex data into a summary we can understand and compare. So we have different types of central tendency, and the main types are: the first one is the mean, which is the arithmetic average of all the observation, and it is used for numerical data, continuous or discrete. Then another central tendency measure is the median, and the median is the middle value after order. So we need to order our data from the small to the highest value, and the middle of this data, meaning 50% of data are is about the median, and 50 is I mean 50% is above the median and 50% is below the median. Here also it is used for numerical data, and what is good with the median, it is that since it doesn't take into account all the observation as the mean does, so it is robust to the outliers. So when we have outliers, it is better to use the median than the mean. And what do we mean by outliers? Actually, the data point that deviates significantly from the rest of observation. And now let's talk about the mode, which is the third type of central tendency. The mode simply is the most frequent value. So here the mode is perfect for categorical data. It is used for numerical data as well, but for categorical data, since we cannot use the median and the mean, the mode is perfect in this case. And now let's see how to calculate those central tendency measures. Let's start with the mean. So as we said, the mean takes into account all the observations. So it is simply the arithmetic average. So mean, or x bar, is the sum of all the all the data point divided by the number of observation. Here for raw data, or we can write it as x bar equals the sum of FE. FE here is the frequency of each data point times the value of this point divided by the sum of FE. Here, if we have organized data in frequency table. As an example, imagine that we have this two sets. The first example is the number of siblings. We have 2, 4, 2, 2, and 3. And the second example this is for raw data, and here for organized data. So how to find the mean for both? So for the first, it is the sum of all values divided by the number of observations. So 2 plus 4 plus 2 plus 2 plus 3 divided by 5, which is the number of observation, we get 3. So the mean here, the mean here is 3. And for the mode, it is the most frequent value. If we check here, the value there that is repeated most here is 2. 2 is repeated 3 times, while the other values are not repeated. So 2 here is the mode. So x bar, which is the mean, is 3, and the mode here is 2. Now let's see how to find the mean for this data set and also the mode. So for this case, we will use this formula, and here it is. So x bar is the sum of FE times XE, which is this one, and we got 58 divided by the number of, or the sum of frequencies, which is 20. So 58 divided by 20, we get 2.6. This is the mean. This is how we calculate the mean. For the mode here, it's even easier because it is already organized, so we need just to check the frequencies, and the highest frequency here, which is 8, so the mode is the value that has the most or the highest frequency, which is 3. So the value of the mode here is 3. So this is how we calculate the mode and the median for organized and raw data when we have discrete data. Now the mode and the mean actually. So now let's see how to find the median in case of discrete data. So as we said, how we define the median as the middle of data, where 50% of data is above the median and 50% is below the median. So how to find the median? The first step to do is we need to order the data from the smallest value to the highest value. Then we have two situations. If n, which is the number of observation, is an odd number, the middle value is simply n plus 1 divided by 2. So the middle value is the n plus 1 divided by 2 value. In case here n is an even number, here in this case we have two positions. So as we said, for n is odd, the position is n plus 1 divided by 2. In case it's even, we have two positions. So the first position is n divided by 2. It is the n divided by 2. This is the first position. And the second position is n divided by 2 plus 1, which is actually the next value after this one, the next position. So how to find the value of the median here? We need to take the average of those two values. It will be clearer through an example. So let's see an example. Now imagine we have this data set. We start with this one, the first one, with an odd number. Here, as you can see, we have 5 observations. So the position of the median here is the third. How we found 3? So we applied our formula here. N plus 1 divided by 2, because it is an odd number. N is 5. 5 plus 1 divided by 2, it is 3. So the position here is 3. The position of the median is 3. How to find the median? So the first thing we need to do is to order the data. We cannot keep it like this, so we start with the smallest value, which is 2. 2 is repeated 3 times, then 3, then 4. Where is the third value here? It is 2. So as we said, the median is in the third position, so the third value is the median, so it is 2. Here the median is 2. Now let's see in case we have an odd number. Here we have an odd number because the n here is 6. We have 6 observations. So how to find the position? As we said, we have two positions, actually 2 ranking. So the first one is n divided by 2. 6 divided by 2, we get 3. And the second one is the next position. The next position is the fourth position. So and 4. We take actually the average of the third and the fourth value. Where is here the third value? It is 2. Where is the fourth value? It is 3. The average of 2 and 3 is 1 divided by 2 times 2 plus 3, or directly 2 plus 3 divided by 2. We get 2.5. So this is the median for this case. And now let's see how to find the median when we have discrete data but organized in frequency table. So we have this example where we have 20 observation, which means n here is an even number. So as we did with the raw data, we need first to find, we need to organize the data and rearrange them to get like from the smallest value to the highest value. So we start from 1 until 4. We have our frequencies. So the total, or the number of observation, is 20, which is an even number. So we need to find the median. So to find the median, we need first to find the position. Since it is an even number, we have 2 positions, and we will find the average. So the first position, as we said, is n divided by 2, which is 10. This is the first position, and the second position is the next one, which is 11. So how to find those positions here in this, in case we have organized data? So for the median, we need the cumulative frequency less than. So we check here. We said the first position is 10. So where to find 10 here? So as you can see here, the 2 first value are here. So the 2 first value are 1, and from 3 to 6 it is 2, from 6 to 14 it is 3, and from 14 to 20 it is 4. So anything between 6 and 14 is actually 3. So the 10th position is 3, the 11th position is 3. So how to get the median here? It is 3 plus 3 divided by 2, which is 3. So the median here is 3. This is how we calculate the median. When we have organized data, we need the cumulative frequency less than. So when you want to find the median, it is crucial to find the cumulative frequency. It is important. And now finally we will see how to find the mode and the median in the graphic when we have discrete data. So for the mode, it's very easy. You have your bar chart. The tallest bar, the highest bar, is the one that represents the mode. So here, this one is the highest one, with 8 as a frequency. So 3 is the mode. This is how you determine the mode graphically. For the median also, it's easy. You need just to draw the curve or the stair chart here for the cumulative frequency less than and more than, the cumulative frequency more than, and where they intersect, this is actually the median. Here it is also 3. So this is it for this video, and in the next video we'll see some other measures of central tendency, like quantiles. So see you in the next video.